So guys, good evening all of you. So in the last classes we have discussed about the what are the difference between the version 1 and version 2. So we have discussed for example, this one version 1 information and this one version. For the version 1, what happened by default, all the broad all the update packet will send on broadcast at 255 global broadcast address, right? Okay, then it is classful. It does not support summarization. Then it does not support authentication. Authentication, we have a clear text and MD5. Then it does not send subnet mask information in update packet. Perfect. So these are my some difference of some information on the version 1, whereas version 2, all the update packet will send on 224.0.0.9 by default. Okay, it means that we can change it. So can we please record? I'm recording, Rajveer. Okay, by default it's an update on this address. Then after that it is classful, sorry, classful and classless as well as. Then we have it support authentication, that is my MD text format. Okay, and another is MD5. The MD5 is much secure as compared to text, because whatever the information, if you apply the authentication CCI in the text format, that will be sent over the link, right? And this link or the CCI, you are sending over this link, so any hacker is there, they can easily see your password. So this is not a good type of authentication. This is the text, that's why we are going to use the MD5. It does support summarization, and then we have a, guys, the spelling will mistake, just ignore the spelling. And then we have a, it does send subnet mask information in update packet. Clear? So these are the things that we have seen in the last class, yesterday class, right? What are the difference between version 1 and version 2? And how do I enable the RIP? Just put the command router RIP. Okay, this command is just, when you put the question mark, you will have an option of RIP, BGP, OSPF, ISS protocol. Then we have a EHGRP, lots of protocol information you have, which protocol you are interested to run. So router is just going to tell you which protocol protocol running you are interested, right? I need to say that, okay, I'm interested in the RIP protocol, right? Then define the version 1 and version 2. I'll say that version 1 network x.x.x, and that's exit. So network command, first use, it advertise the network. Second, it enable the interface into particular routing protocol. Third use, it join the multicast group. Perfect. So this is the by default things that I let you guys. We can change this guy as well as this guy. We can make it in broadcast as well as if you want. Okay. So let's see the another thing. For example, this is my router. As we know that what is the use of network command, it's going to enable the interface into the particular routing protocol. This guy is going to enable the interface into the particular routing protocol. So once this guy will enable the interface into the particular routing protocol, whatever the updates you have, it will send on that interface, right? And update will be a periodic, and that contains the up to 25 dots. Okay, so for example, this is my router number 1 and this is my router number 2. Router is the layer 3 device, okay, and that has a connectivity with the LAN interface, my switch network, and this is my user 1, okay, and this is the LAN network behind the R2. That's my loopback over there, 2.0.0.0/8 information. Okay, we have an interface behind the LAN network. This is my 0/1, so R1, R2, 12.1, 12.2. This is my LAN information. We can say that 1.1, 1.100 either we can say the gateway of this guy, and this is a 1.1 IP address of this guy. So we are using the class A IP address 1.0.0/8. So this interface will be 0/0, and this interface will be 0/1. When I'm going to enable the router rip on R1 router, for example, this is my configuration for R1 router rip version 2 network. What happened by using this command? This command is just going to enable the interface into the particular routing protocol, right? This command is just going to enable the interface into the particular routing, this interface, right? So what happened if this guy is going to enable the interface? R1 is sending the update. Try to understand. R1 is sending the update to the R2. Perfect. This information I'm sending to you. You have to be installed this route in the routing table 2.0.0.0.0, right? And this is my layer 3 information. I'm sending a packet the layer 3, right? And layer 4 as well, as that has a layer 4 and layer 7 information. The RIP is a layer 7 protocol. But what is a router? Router is a layer 3. They can learn the packet, right? This guy has the ability to receive this packet. What about the switch, guys? Switch is a layer 2 device. It's layer 2. It's layer 3. Which packet I'm sending to this guy? What information in this packet I'm sending? This is my RIP update packet. And what information I'm sending this in this packet? 2.0.0 information. This guy. Sending this information to this guy. LAN network. At every 30 seconds. A periodic timer. Now tell me one thing. I'm sending this information to the switch 1, and switch 1 is the layer 2 device. What switch will do? Drop the packet. Or for example, if you say that, okay, why should it drop the packet? It will accept the packet because it has the layer 2 information as well as, right? So based on the layer 2, they can receive the packet. Okay, let's take an example. It will receive the packet, layer 2. After that, just tell me one thing. Will a switch is going to maintain the routing table? No. Then why should I send the update to this guy? If switch 1 is not going to maintain the routing table, why should I send the update to this guy? This is not a good thing, right? You are sending the update to this interface on the switch 1 that is never understand this packet, because switch 1 is a layer 2 device. A layer 2 device does not maintain the routing table. You are sending this information on the WAN interface, perfect, because there is a router can receive this information and put this out in the routing table. But why should I am sending the packet on this interface? Switch 1 will never maintain the routing table. So thing is that whenever I'm putting the network statement 1.0.0.0, this interface will be enabled in the RIP protocol. And once this interface will be enabled in the RIP protocol, what happened after that? I will join the multicast group and keep sending the update to the switch 1. So you are making, by enabling this interface, you are making this guy as active. This guy is active. And this guy is active. So perfect. This guy is active. This guy is active. Perfect. They can exchange the information. Router is used to exchange the routing information. But what about the LAN network? You are keep sending the packet at 30 seconds. Just wastage of the bandwidth and process CPU. So you are going to wastage of the bandwidth of this link. At the same time, for example, at every 30 seconds, you are sending the one packet, right? That one packet will consume a 20 kbps of bandwidth, right? And if you have a thousands of the information, if you have a thousands of the information on the router, because this is a routing protocol, RIP is a dynamic routing protocol, then how many packets you are going to send? Thousands of the routing information you have. You are going to send the 40 packets in 30 minutes. Sorry, 30 seconds. And each packet, just take example, one packet is going to consume your 20 kbps of link. Then 40 packets is going to consume 20, almost 600 kbps at every 30 seconds. If I'm not wrong, this is the math. I'm not good with the math, right? So in a 30 second, you are consuming a 600 kbps of bandwidth. That's okay. Let's say that okay, it's not a big deal, right? I have a link of the 10 mbps link. I'm take the 10 mbps link of this guy. It's not a big deal, man. CPU, process of the router as well as switches. You're going to increase the process of the router as well as switches. So this is not a good thing. So to avoid this problem, what I'm going to do, I'm making this guy as active, right? I'm making this guy as active, and this guy is also active right now, and this guy is also active. That's why we are sending the packet to this interface. Let me make a passive. So if I'm going to make the passive, try to understand one thing. If I'm going to make the passive, what happened? R1 stop flooding, RIP update on 0/1 interface. That is this guy towards the LAN. Whatever the R1, but R1 can send this information, this LAN information to the R2, and R2 will have this route in the routing table. That's why we can ping that. This is the reason that R2 can ping this network. So R1 will send the update LAN information to the R2, but R1 will never send any update to the switch. This is done by the passive interface. So I'm going to make this passive interface 0/1. Once I make the passive interface 0/1, what happened? The R1 will never send any update to the switches. And in this way, what happened? You are just going to reduce the wastage of the bandwidth of the link, CPU, and the process as well as of both the router and the switches. Okay. So you can enable the passive interface. Just put the command on a router rep. Version 2. You can enable the version 1 as well as. It's totally up to you. This command will support in the both. Version 2 passive interface 0/1. Okay. Now you have question law. What happened if you have a 10 interface on the router? Just take example. If you have a 10 interface on the router, 0/1, 0/2, 0/3, 0/4, 0/5, 0/6. So how is it possible that I'm going to mention the over there? Okay, passive interface. 0/2, 3, 4, 5, 6, 7. Is it like that? No. You are just now you are just increasing the memory of the router. Now you are just going to increase the memory of the router. You are putting the commands, and whatever the commands you are going to put on the router will store this command in the running config. And of course, you are putting this command in the running config, they will take the memory of the router as well as. So again, this is not a feasible solution. So if you have a single interface, you can do that. If you have a single interface, you can do that. But if you have a multiple interface, you can't. Right? So what I'm going to do over there, I just need to say that passive interface default. So default keyword, what this keyword will do? It make all interface as passive. But the thing is that if I'm going to make this interface as a passive as well as this interface, as well as this interface, So what happened? You are making this interface is good. You are making this interface is good. But if you are going to make this interface, what happened? R1 is not going to send any update to the R2. So if R1 is not going to send any update to the R2, after the 240-second, that is my flush timer of the RIP, router 2 is going to remove this route 1.0.0 from the routing table, and whatever the user behind this R2 and whatever the user behind the R1, they cannot ping, they cannot send any traffic. So what I'm going to do, I'm just going to apply all the interface as a passive, but no passive fast Ethernet 0/0. I'm not going to include the say guy, the passive one. Perfect. I'm not going to include this guy into the passive. So let me implement this thing, JNS3. I think so. I have that project. Okay. Passive interface. RIP. Implement the passive. Passive interface. RIP. So guys, this passive interface works like a same in the RIP and GRP and OSPF, right? So this one dialed router 1 or router 2, and this is the one or more router that works like a PC. And I'm going to take the one switch, Ethernet switch over there. Perfect. So R1, R2, switch 1, and R3. I'll make this guy as a PC. So change symbol and classic, and I'm saying that this guy is a computer. Zero slash zero is a switch 1. Then Ethernet 1 slash on the router number 0/0. 0/1 with this R2. Start. This guy will be 12.1. Network IDs /24. This guy is 12.1. This guy is 2.0.0/8, and this guy is 1.100. This guy is 1.1, and this guy is a 1.0 submit the LAN network /8. Perfect. So network map, enable the interface. Protocol. Second. Third. And I done one more thing. It make the interface active so that RIP router send the update packet. Okay, so let me take the console of the R1, R2, R3 and switch as well as the PC. So this is a behave like a router right now. I'll just make this guy as a PC. Just disable the routing behavior on the router number 2 as well as. So right now I'm just going to define the IP addressing. I'm not going to enable the RIP. Config terminal interface 0/0. This one is my 12.1, sorry 1.1, 1.100 Android /8. No shutdown interface 0/1. IP address 12.1. Come on. /24. No shutdown. Perfect. Do WR. Save this configuration. R3. R3 is my this guy, right? This is the right now. So I'm just make this guy by default. This is behave like a router. I'll just going to disable the behavior of the routing. So if you have a look over there, 1.1.1, if I'm going to put the IP address, what happened? They will maintain the routing table, right? They will maintain the routing table. So what I'm going to do, I'm just going to disable the behavior of the router. I'll make this router as a PC. Now clear? Now do so IP root. Now he's asking what is the gateway. Default gateway is not set. So let me put the gateway, IP default gateway, and gateway is 1.1.100. This interface. This will be a gateway of this PC. R2. So far as good, we have just done the IP addressing on this guy as well as no IP routing to disable the behavior of the routing. And now R2 interface 0/0 IP address 202/24 no shutdown interface loopback number 1 IP address /8 loopback does not have a MAC address. Save this configuration, and this guy also save this configuration. Do double. Perfect. I'm just going to take a capture of this link as well as this link. Okay. So two links has captured. Okay, this one is not perfect. And now I'm just going to enable the RIP on the R2 router first. Router RIP version 2 network 12.0 and in network 2.0 as my loopback. And if you have a look, do debug IP RIP. This guy is enabling going to interface into the particular routing protocol. So it will send the update to the loopback number 1 as well as this is my loopback number 1. So it behave like a different broadcast domain. So on this loopback, they will also send the update on this link and this link as well as, because both are part of the network command right now. On which interface? 0/0. This guy. Then loopback number 1. Perfect. So let's go now R1 router RIP version 2 network 12.0 network debug IP RIP. Receive the update from the 12.2. That's perfect because it's my layer 3. I'm receiving the update from the 12.2. Perfect. This guy. Sending the version 1 update on the 0/1. This interface. Good. Sending the version 2 update on the 0/0 on the LAN interface. Not good. Just wait for a 30-second more. It will send the more update. Sending the version 2 update again. 0/1 interface. That's good because it's a layer 3 on the layer 3 device over there. And they can receive the update and they can maintain the routes in my routing table, right? In their routing table. But why should I send this update to this guy? A LAN network. And which information I'm sending? This two information I'm sending to the switch. Will switch will understand this route? Never. It's a layer 2 switch. It's not a layer 3. It's a layer 2 switch. Switch will never understand this information. And see, after that, I'm receiving the update from the 12.2. He's also sending the update to me, and I'm accepting this update. But I'm not receiving any update from this neighbor. Then why should I send the update to you? It's something like that. No? There is a guy over there. He's talking to me, right? So we are also exchanging the information. Both the guys are exchanging the information. But what happened? There's a one guy over there, and there's another guy that know the language French, and this guy is know the Hindi. You are calling this guy and making a conversation, but you are making a conversation in Hindi. But this guy will never understand because this guy does not know Hindi. So you are totally wasted, right? Same thing is happening. You are sending the update to this guy, never understand. It will never understand the layer 3 information. I'm only receiving the update from which guy? 2, but not from the switches. if you see the Wireshark as well as this is the capture of the R1 and R2, right? This is the capture of the R1 and R2. So we are extending the information 12.1 sending, 12.2 sending, 12.1 sending, 12.2 sending. And this is capture of the link. But if you see over there in this capture, the LAN network, only 1.100 is sending the update. Only 1.100, 1.100, 1.100. Only 1.100 is sending the update to the this guy. So it's not a good thing, right? So what I'm going to do over there, I'm just going to make R1 router rip passive interface. Which interface? My LAN network. And LAN network is 0/0, right? Hit enter. Now I will never send any update. You see the Wireshark is there. So it will also know this was the last packet, right? This was the last packet. So if you have a look over there, I'm only sending the update on which interface? 0/1. That's my WAN interface. R1 to R2 connectivity. This man 0/1. And this man 0/0. I'm not sending any update to the LAN network. But I'm sending the update to this guy. I'm receiving the update from there. Again, I'm sending which interface 0/1, but not sending to the 0/0. Receiving from there. Again, I'm sending to the 0/1. So have a look. I'm not sending any update to the LAN information. No information. Everyone is 0/1, 0/1, 0/1, 0/1, 0/1. If you verify this thing, use to IP protocol.
Hello.
Yeah.
Hello.
Yeah. Tell me.
Yeah. This RIP protocol is not in the syllabus, right?
Yeah, I know RIP is not in the syllabus. I know this
Okay,
thing,
so
Raj. See, we just discussed this thing because you must have a knowledge, right, about the because you go for the CCNP entire label, right? So if someone will ask you what is RIP, then what is the answer you have? I know this thing not so just give me the 2 and 3 days as well. Let me complete this thing. So you will have a good picture of the HRP. You will have a good picture of the whole stuff.
Okay. No problem.
Okay.
Actually, this is my first class. That's why I asked this question because
Okay.
I
Okay.
will,
No
I
issue.
will
No
not.
issue. No issue. Okay.
Okay. And okay. Thank you.
So have a look at the we have enabled the passive interface 0/0. But what happened, guys? Just take example. If I'm going to enable passive interface, let me get no passive interface 0/0. Now it will send the update to this guy as well as just wait for some time. Now he's sending the update on 0/0. So what happened if I'm going to make the passive interface right now? If you go on R2 router, so if you do, I have the information right, and I can send a traffic to this guy as well as clear. But sorry, come on, yep, right. But what happened if I'm going to make the passive interface default? This keyboard is going to apply the passive on each and every interface. Now I will never send any update packet. All the interface 0/0, 0/1, and 1/0. Okay, and now I will never send the update. So if you go on R2 router, sorry, swipe root, timer has moved in the 41 seconds. It has crossed the 30 second, right? It has crossed the 30 second. So after the 240 second, what happened? This guy will remove this route from the routing table because R1 is not sending any update. He's only receiving the update, but he's not sending update. So if I'm not going to tell you about my network, what happened after the 240 second, you will remove this route from the routing table. after the 240 second. That is the first time, right? So R1 is not sending any update because I have enabled the passive on this guy, passive on this guy. But I can accept, huh? Because I have a ability to accept the update. So I can accept you. But I will never send any update to you. So just wait for the 240 second. So right now I'm only receiving the update. Just gonna out on 2, swipe root, and you have a 138. I'll make the one. Okay. Um, 640. I think so. This one. So swipe root. 2 minute 21 second. So if you check an R1, I'm not sending it, only I'm receiving the update, right? Because I have enabled on each and every interface as a passive. So this interface is also become the passive. This interface also become the passive. So I will never send any update. So in this way, what happened? You can reduce the CPU, but you have to be enabled right on this guy. Because WAN should be enabled. On every time we are on LAN interface, we make it a passive. So I will it's down. It's possibly down. It has crossed the 180 second. So now the metric will be 16 now. Let me show you. Okay. So now just wait for the few minutes more. So slow routing protocol. That's why we are not going to use in the market right now. Swipe it. Then removed. There's no one or zero now. Previously it was there. Now it's not because he's not sending any update. So what I can do on R1 router, I simply say that no passive interface, 0/1. Now I can send the update. Receiving. Sending. Perfect. Now R2 will receive the route. Clear? So if you want to provide the communication between the R3 to this guy to this guy, look back from here to here. So we can easily send the traffic. Done. So this is the way that you can implement the passive interface. Okay. So anyone has a question, guys? Okay. Now, let me talk about, okay, we have seen that thing. Okay. I'll tell you about the split horizontal. What is the split horizontal? Used to prevent the loop, right? It is used to prevent How? What is saying? What Spirit Horizon is saying that R1, R2, R3. R1, R2, R3, 12R1, 12R2, 23R2, and 23R3. 0 slash 0, 0 slash 1, 0 slash 0, 0 slash 1. R1 has some update. 1.0.0.0. R1 put the command router rep network 1.0. So what happened when I advertise this number? R1 is going to send this information to the R2, right? This information 1.0.0.0, right? As a slash 8 information, because this is a version 2 I'm running over there. So this is my version 2. That's why putting the submit mask information. This information is present over there because of the version 2. In a version 1, we don't have a CIDR, or we can say that submit mask information. So once R2 will receive this update, on which interface they are receiving this update? 0 slash 1. On this interface 0 slash 1, by default, split horizon is enabled on every interface. So if the split horizon is enabled in the interface, what happened? What split horizon is saying that whatever the update that you are receiving on which interface 0 slash 1, I will never share same update back to this interface, but I will share this update to the R3. Whatever I'm present on R2, whatever the update that I'm receiving from my neighbor, I'm present on R2 router. Whatever the update that I'm receiving from my neighbor, on which interface 0 slash 1, I will never share the same update. I will never back to the address, same address to this guy, but I will share this information to my next neighbor. This is the meaning of a split horizon rule. So if I'm going to do that, what happened? If R2 is receiving the update and R2 is going to say advertise this update. So this is the loop, right? And this is not happen because of the split horizon is enabled by default on this interface 0 slash 1 and 0 slash 0. So what happened if I'm going to make a disable on this guy? You are going to create the loop. Now R2 will share this information to the R1 as well as. Let's see. So we should check over there on R2 router. Just go on R2 router and say that show interface 0 slash show IP interface. So first of all, he join the multicast group, right? Every interface is going to join the multicast group, whatever the interface that is enabled in the RIP protocol. That's 2 or 0 or 0 NAT. That's the RIP. And have a look. Split horizon is enabled. Split horizon is enabled. So what I'm going to do over there? Let's see. I'm going to say that router RIP interface 0 slash 0, no IP, split horizon. So if you put the question mark, either you can put the enter over there, or either they are asking for the EHR bit. So I'm in disabling the split horizon rule for which guy? RIP. I just put the enter over there. That's it. Because if I'm going to use the EHRP, it will enable, it will disable for the EHRP. I'm going to disable for the RIP. Now have a look. Previously, I'm sending the update. Let me show you to you all. Previously, let me copy the previous update. Not this one. Not this one. This one. I'll copy this thing, and the notepad. Okay. Format, font. Perfect. And done. And after that, I have a new, after the disabling the split horizon, we have a new update. Not this one, this one. So this is after disable split horizon. split horizon enable. Okay, there's two information, there's two output, one output for the enable, one output for the disable, right? Now in the enable, what happened? R1, R2, R1 has update 1 or 0 or 0. R1 is sending the update to the R2 on which interface 0/0. What happened? R2 will have this route in the 1 or 0 or 0 information in the routing table, and R2 is going to share this information to the R3 as well as, right? This is a split version of the enable, right? This is the information for the enabling. Now he's not going to share this information to the R1 back to the R1, right? After the disabling, what happened? Sending the version 2 update. It was also sending the version 2 update, but I'm only sending the 2.0.0, right? R2 is only sending the 2.0 update, right? But after disable, what happened? Now R2 will share the this information as well as my own information to the R1. So, but this time, what I'm going to put the matrix. Clear? So you are going to make the loop over there. This is the bad thing, right? This is the bad thing because you are sending this information to me, and I'm back to the same information I'm going to say to you. Of course, the route R1 will not prefer because of the lower AD, as AD is 0 for this guy, and I'm learning this AD is the 120. Of course, R1 will not prefer. But again, you are sending the same information to me, so you are creating the loop over there, right? So this is not a good thing, right? This information. This is not a good thing. So to avoid this thing, we have to disable the enabling the split horizon rule. By default, this thing is enabled. If you're going to disable this thing, then you are going to make a loop. So maybe you have a question, law. If the command is there, no IP split horizon rule, then what is the use of this command? Where I can use this thing, guys? You can use this thing in the. I'll show you in the DM VPN. Okay, you have to disable the split horizon rule in the DM VPN part. Otherwise, the router will not learn the route. Okay. Now let me introduce all the information about the protocol. You all SWI protocol. The first one is sending that outgoing filter. I'm not applying any filtering over there. Not set. Incoming update filter. I'm not going to apply any filtering over there. That's why he's asking for this information. This two information about the filtering. So I didn't set over there. That's why he's saying a no set. Now, our next line is saying that sending update every 30 seconds. Sending update at every 30 seconds. As we know that we have a timers, the RIP timers. That is the update is 30 seconds. So at every 30 seconds, router 1 is going to share the update to the R2. And in this update, the R1 is going to share the complete routing information. In this update, the R1 is going to share the complete routing information. Let me show you. Let me enable this thing, IP split horizon first of all, and then so IP route. What is the timer? 21 seconds, 25, 26, 1. So at every 30 seconds, the router is going to share the complete routing information to the R2. Complete routing information. At the first update, share the update. Second, share the update. Third, share the update. Fourth, share the update. Same information I'm sending at every 30 seconds. Is it good? Bad. This is another reason that why we are not preferring the RIP in the market, guys. This is another reason. So you have seen that 25 seconds, 26, now 1. So I'm updating my information, right? I'm updating my routing table information because you are sending this information to me. But this case will not happen in the GRP NoSPF and even the BGP. Because that guy is not sending the periodic update. Okay. Next information. This is sending the update at every 30 seconds. Next update I'm going to send in the 8 seconds, right? Next to in the 8 seconds. So this is the timer of this guy. And next update I'm going to send in the 8 seconds. Invalid is 180 seconds. What is the meaning of invalid over there? So if you have a look over there, what's happening? We have a timers of the RIP. The first timer is update, second timer is invalid. So update is 30 second, invalid is 180 second, hold on is 180 second, and plus is 240 second. Now what is the meaning of update? Update means what? I'm keeps updating you at every 30 second, and in this update packet I'm going to put the routing table information, right? Now what is the meaning of invalid? Invalidate R1, R2, one or zero or zero or zero slash 8, right? 12 or 1, 12 or 2, R1, R2. At every 30 second, I'm going to send the update to you. R1 is going to send this update to the R2. 1 or 0 information slash 8, because this is the submit mask information is a version 2 packet, right? Sorry. Okay, so R2 is going to maintain the routing information. I'm loading this information from the RIP protocol that has a 8120, and thus has a matrix is 1, that is a hook one. I'm learning this information from the next of 12.1, and I'm learning this information from which interface? My own interface 0/0. This is my own interface. So I'm learning this information from which interface? 0/0, because I can learn the same route from the R3 that has a 0/1. So I'm mentioning that I'm learning this information from 0/0. Now what happened? This is the route is present in my routing table. This route is present in my routing table. Invalid. So the thing is that R1 is keep sending the update to the R2, keep sending the update at every 30 seconds. At every 30 seconds, keep sending the update. But what happened if R2 is not able to receive, or if R1 is not able to send any update to the R2? What happened? Try to understand what happened that R1 is not able to send any update to the R2. So for example, once I receive the update, my timer is right now 1, 2, 10, 20, 25, 26, 27, 28, 29, 30. If I'm not able to receive any update till 30 seconds, what happened? Now I'm moving in the invalid state. I'm moving in the invalid state. Now the 31, then it will be the 40, 50, 60, 70. My route is still there over there, 80. And I still send any traffic to this network. I can still send any traffic to this network. 90, 100, 120, 140, 160, 170. I still can send any traffic to this network, even I have the route in my routing table. And the route is normal look like this one: 170, 175, 176, 177, 178, 179. Once the timer will reaches to the 180 second. Once the timer reaches to 180 second, what happened? Now, this route is look like this one. It will say that possibly down. Possibly down. He's just threatening you, right? R2 is just threatening that possibly down means that I'm just further 60 seconds. I'm just going to wait for that. That is the range between this guy 180 to the 240. What is the range between this guy? 60 seconds. I'm further going to wait for the 60 second, right? But still 181, right? This route is possibility 181 or 182, 200. Still I can send the traffic to this network. Still I can send the traffic to this network, ping 1 or 1 on, and even my route is present in my routing table: 2110, 220, 230, 235, 237, 238, 239, 240. Once it reaches 240, what happened? I'm going to remove this route from the routing table now. And now I cannot send any traffic to this side. This is the meaning of update timer, invalid timer, or flush timer. Flush means what? Just remove this route from the routing table. If I'm not able to receive any update till 240 seconds. If R2 is not received any update from R1 till 240 seconds, I'm going to remove this route from the routing table. That is the meaning of flush timer. Is that clear now? Okay, now let's take another again example. I have a R3 now. In this case, I have a R3. Okay, R3 has a 12 or 23.2, and this guy has a 23.3. Okay, and we have some information behind the R1, R3 also, and the same information 1.0.0/8. Same information over there. Okay, right now I'm not going to enable the RIP over there. Just take example. I'm not going to enable the RIP over there. Okay, continue from again. R1 has sent the update to the R2. This update 1.0.0.0. R2 is going to receive this update on 0/1 interface, and it will maintain the routing table. Okay. Now what happens if R2 is not able to receive any update? 10, 20, 30. It will move to the invalid state. 40, 60, 90, 100, 140, 160, 170, 175, 176, 178, 179, 180, 181, 182. Guys, in this scenario, what happened? 182 is the timer has crossed the 180 second. That has the moving the first timer, right? In this case, what happened? If I'm going to enable the RIP over there, and R3 has sent the same update to me, R3 has sent the same update to me. What happened? Now I'm going to maintain the new routes R 1.0.0.0.0. Next stop 8120 matrix 1. Next stop will be 23.3. From which interface 0/1. So if R2 is going to send any traffic ping 1.1.1.1.1, what happened? If the packet is coming to me R2 router, destination is 1.1.1. Look up the routing table. Do we have information for the 1.1.1 network? Yes, according to the routing table, forward the packet to the 12.1 to this guy from which interface 0/1. Okay, fine. My next stop is, so my source will be always exit interface 12.2, right? Again, next packet 1.1.1. Do we have information? Yes, I have information according to the routing table. I need to forward the packet to whom? 23.3 from which interface 0/1. Loop. Some packets go this link, some packet 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 go this link. You are just creating a temporary loop over there. You are just creating a temporary loop over there. And this can happen, man. It's not a big deal, right? R3 can send the same update to your R2, and R2 will receive it. R2 will receive it, and by default they will perform the load balancing. So this is not a good thing that you already have a one route. You already have a one route, and that is moving in the flush timer. At the same time, you are able to receive the update. So to avoid this problem, to avoid this kind of loop, what we have introduced the concept of hold on. Hold on means what? A router is going to create the hold on state. This is the hold on timer, or we can hold on state over there. Right? And that has a timer that has same timer like invalid 180, 180. Both have the same timer. Okay. Once the route has crossed 180 seconds, the route will move in flush timer. At the same time, the route will move in hold on state. if any route if router 2 is receiving any update from any neighbor, and check the update and compare with hold on, if the same route is there, then router will never accept the update. Right? If route is different, then router will accept the update. Clear? So just take example. What happened? Again, same scenario. R1 is sending the update. R2 will maintain this update in the routing table, right? But some case what happened? R1 is not able to send any update to the R2. Router will move in the post invalid state 30, 40, 60, 150, 160, 170, 175, 180. As this is 180, what happened at the same time? I'm going to make this possibly down, okay? And I'm going to put this route in the hold on state, that is 1.0.0/8 from 12.1. Now what happened? This route is over there. At this case, what happened? Now the time is moving over there, 180 to 190, 190 to 200. At the same time, what happened? R3 is going to send this update. In this update, same update is there, 1.0.0.0/8, right? When R2 will receive this update on this interface 0/1, what R2 will do? Okay, the update is 1.0.0. Let me compare with the my hold on state. Okay, update is same. I will never accept this update till 240 seconds. But if you are sending the another update that has a maybe 2.0.0.0.0, okay, I will accept this update. I will put this route at the same time in the routing table. I will put this route at the same time in the routing table. The update is different. But if the update is same, I'm just compared with this guy. Okay, the update is already there 1.0 in my hold on state. I will not going to accept this update. But if the update is different, I can accept this update. So this is the way that you can prevent the loop by in the hold on state. And that loop is a temporary loop. Okay, so this is the use of hold on state, guys. Let me show you this thing. I'll make the same topology is there, right? What I'm going to do on a R2, R2 is able to receive the update right now. So IP route, perfect, 20 seconds. So it keeps updating out there. Now 25, now 1, right? It's keep updating out there. What I'm going to do on a R1, first on R2 router, I'm going to enable the debug IP routing, debug IP route, sorry, RIP. At the same time, I'm going to take a, let me delete this guy, this link. I'm not interested in this link right now. And even the switches. Yes, I want to delete this guy. And I'm going to just make this guy as a router. This is my router. Change symbol. The router picture is not there. Okay, this is my router, guys. This is my router, right? This is actually is a router. Let me connect the interface over there. 0/1 to this guy. 0/0. Okay, so I'll put the IP address. Let me remove this guy first. No, so this is the IP address of this guy is a 23.2, and this guy is a 23.3, and we have a same information behind the R1, R3, that is the 1.0.0.0/8. Okay, and this guy also have the same information 1.0.0/8 as a loopback. Perfect. So R2, let me first interface 0/1, IP address 23.2, no shutdown. On R1, let me do one thing, interface 0/0 shutdown, or no IP address, I can say that. Interface loopback number 1, IP address 1.1.1/8, right? And perfect. R3 has a 0/0. Let me enable the IP routing first, make the router, or interface 0/0, no IP address 23.3. Perfect. And I'm just going to create the one loop back, that is a 1.1 same loop back, right? And I'm going to say the router rip version 2 network 23.0 network. Okay, do debug IP rip network 1.0. I'm not going to put the enter right now. I'm not going to put the enter. I'm just going to put it like this. I'm not going to put the enter. R2 router rip version 2 network. Okay, so that it enable the interface. Perfect, right? Now what I'm going to do right now, if you check the routing table, I have a route from where 12.1, right? R1 is sending this information 1.0.0, right? R1, let me do one thing, no interface loopback number 1. I have this update, right? 1.0.0. Clear? Let me do one thing, do run 600. So far it's good now. Now what I'm going to do right now, guys, try to understand. I'm going to enable this interface into authentication. Okay, I'm just going to enable the authentication over there. So if I'm going to enable the authentication on this interface, what happened? R1 is not going to send any update to the R2, right? This update. So R2 will R2 will have this update to 1.0.0 in my routing table, but now this update has a going to be expired, right? So let's go on R1, and I keychain will be a, key ID will be 1, key string will be CCI, interface 0/1, IP rip authentication, keychain A. So by default it will take the clear text. So just go now R2 router and check the command, do show IP rip, show IP route. Update is 24 seconds, 29, 33. It has moved in the invalid state, guys, right? It has moved in the invalid state. This guy has moved invalid 180. 40 seconds. Ping. Still I can send the traffic, right? Still I can send the traffic. So IP route 56. So IP interface 0/0. Perfect. So IP route 1 minute 20 seconds. Ping. Still I can send the traffic. Just wait for the 180. 130. So on a R3, I have advertised this interface. I just need to put the enter command over there, right? I just need to put the enter command. I'm not putting over there. Once it will reach to the 180 second now, then I'll put the enter. So IP route 1 minute 54 second. 1 minute 59 second. 232. Still I can send the traffic. 242. 247. 249. 252. 254. 256. 258. 300. 302. Just wait. Possibly down. Possibly down, right? Let's advertise this route. What happened? R2 is sending the request, sending the version 2 update to version 1.0.0/8. I'm sending R3 is sending the update. What about the R2? R2 is receiving the update, but show IP route. I will never accept this update. Still from the 12 hour. I will able to receive the update from the R3, right? What update? 1.0.0. This update I'm receiving from my neighbor. 1.0 from the R3, right? But I'm not able to accept this update. Reason I'll let you know. Just give me 1 minute. Still I can send the traffic. If you see, I'm sending the traffic to this guy. Show IP route. Possibly down. It will remove this state after the 240 right? Delete this network. You all try to understand. Now after the deleting this network, let me do one thing. I'll just copy some information from there. The information that is my, just go 300 second. 300, 300, 300, 3. Yes, this one. Just copy this debug notepad. 3 minutes. 180 second. Invalid has crossed. And okay, now copy this update. Just two things. Now at the same time, I'm receiving this update from my neighbor. Okay, and I can send the traffic as well as, so I'll show you the ping as well as. So guys, try to understand this debug. So this is my R2 debug. This is my R1. This is the R3. Okay, this is my R1 has 1.0. R3 has a 1.0 information. So R1 is not sending any update packet to the R2, right? R2 has in the routing to 1.0.0. Why the next hop 12.1? This is the next hop, right? Now, so once 3 minutes, now come to this point, right? 3 minutes cross, what happened? After that, possibly down, that is the invalid state. Routing by the 12.1. I'm just threatening. Hold on state. It has moved in the hold on state. 1.0 is present now. Hold on state /8. So it means that if R3 is sending any update to me, I will accept this update, but I'm not going to update in my routing table, right? To prevent the loop. So have a look. Now R3, R2 receive version 2 update from which neighbor? 23.3. That is my R3 router. 23.3. There's my R3 router. I'm which interface I'm receiving? 0/1. This one 0/0. This one 0/1. But I'm receiving this update from one hop away, a same update 1.0.0, and same update is present in my hold on state. Same update I'm receiving from my neighbor 23.3, and same update is present in my hold on state, right? I will never accept it because still my routing table is in a 12.1 until unless it will not flush, right? Now let's go to the next one, possibly down. Still I can ping, but after that, after the 240 second, let me show you. What happened after 240 second. Now I'm going to delete this information. Now I'm going to accept this information. So now let me reveal this guy. I'm not interested in this debug. Just wasted of time. Now I'm still able to ping in the 180 second, in crossing the between the 180 to 240. I'm still sending the traffic. After that, I've deleted this network. Once I delete this network from the hold on state, right? Now I'm going to update my routing table with a new next hop 1.0.0.0.0.23.3. 0.3 second ago. Sorry, 3 second ago. Clear now. So hope so this timer to clear to all of you guys. Anyone has a questions?
Yeah, I have a question. Like after 30 seconds also we can give this route, right? But it will not install it in routing table.
Yeah, exactly. It will not install in the routing table. See, that's when I'm sending the update. If you go on R3, it was startingly it was sending do you all, and if you have a look now, sorry, just once I put the network statement over there, see, sorry, what happened? So once I put the network 1.0.0, right, on a R3 router, I'm present on R3 router. And once I put the network 1.0.0, what happened? I'm sending the version 2 update, right? And in this update, I'm putting the 1.0.0 information. And the router number 2 is also going to accept this update. Just gonna previous debug. Hold on one. Just gonna 180 second. That is the 180. Just 3 minutes. 3 has completed. After that, I put the enter command on R3. And have a look. Right now, I'm present on which state right now? Hold on. So I will accept this update, but I will not going to update my routing table. Clear, second?
Yeah, clear.
Guys, anyone has questions? Harsha, Jatin, Rakesh, Anika, Sivasa.
Clear, sir, clear.
Okay, so do swipe protocol. So this thing is clear now. This line is clear to all of you guys, right? Redistribution dip means what? I'll let you know the once I perform the redistribution. Just forget it right now. Default, okay. Default version is saying that version 2 and version 2. Why I'm saying the version 2, version 2? Because I've enabled the version 2, right? So if I'm going to enable the version 2, the interface will be enabled in the routing protocol. The interface has enabled in the routing protocol. I can only send the version 2 packet. I can only receive the version 2 packet. Keychain is just going to represent that I have make a one keychain that has a pro authentication. Okay. Automatic network summarization impact by default auto summary is enabled. Routing, leave it this thing right now. Routing for network is means what? I have advertised this 2 network, and this 3 interface has a passive right now. Okay, routing information for source is gateway is 12 or 2. That's my R2 will become my gateway. Distance as a 8 is 120. And last update I get from this neighbor is 11 meter ago. Right? So what is the meaning of maximum path 4? Maximum path 4 is just going to tell you from how many ways I can receive the route. R1, R2, R3, R4, R5. 4 ways, right? So I can receive the path in the 4 ways. So this guy is connected with the one router over there, router number 6. Router number 6 has a 6.0 information that we are running with the RIP protocol, and that has a maximum path 4. So R6 can send the update to this guy, R2, this guy, this guy, this guy, this guy, this guy, this guy, this guy. So in R1 routing table, we have 6.0.0.0 from R2, R3, R4, and R5. All the routes we have in the routing table. That's the meaning of maximum path 4. It means that we are able to do the load balancing. We are able to do the load balance. That's the meaning of maximum path 4. But what happens if I'm going to disable the maximum path 1? The router is only going to accept the route from one router. It only accepts the route from the R2. Even if you have a R3 connectivity, if you have R4 connectivity, R5 connectivity, but it only receives the path from the R2. If you set the maximum path 1 means what? I'm just going to open the single gate. If I'm going to open the single gate, that I can only receive the information from one gate, right? Not from the multiple gate. If I'm going to receive the maximum path 2, now I can receive the information from this gate as well as maximum path 3. I can receive the gate from this way. Maximum path 4, I can receive the information from this way. But once I set a maximum path 1, it means that no update from there, no update from there. But what happened? Just take example. I say the maximum path 1 is there. I only receive the path from this link. But once this link goes down, I will receive the update from this link. When this link goes down, I will receive the update from this link. When this link goes down, I will update from this link. So at the single, if the maximum path set to 1, I can receive the update from one interface. Okay. So by default it's 4. That's why whenever it's perform the load balancing. If you're going to make the maximum path 1, it means that you are going to disable the load balancing. So don't worry, we'll discuss this thing in the GRP part. Okay, I'm just going to give the overview of the RIP so that you have a clear picture of the RIP, right? And you will see the whatever the disadvantage of the RIP that we have overcome in the EIGRP protocol. Clear? So this is my information about protocols. So hope so tomorrow we'll maybe finish our the RIP protocol. Okay, I'll for tomorrow class I'll let you know, guys. Maybe I'm leave because I have to go somewhere, right? So I'll let you know the tomorrow class. But by tomorrow 3 o'clock I'll let you know the timing of the tomorrow we have class or not. Okay. If you don't have a class tomorrow, then on the Monday I'll finish your RIP. Okay, then Tuesday we go for the GRP. Clear? So can you add me in the group of 8 to 10 batch as I'm not getting video? Yeah, Harsha, I'll send the recording of that one, and Jatin, just ping me on my number. I'll add you in the group. Okay. Yeah. Okay. Thank you, guys. Bye.
Thank you, Ra.
Almost welcome, guys. Bye bye.